For this video, we're going to keep with our triangles content, but now we're going to talk about midsegments. So what is a midsegment? It's a segment with endpoints that are the midpoints of two sides of the triangle. Every triangle has three midsegments. So to remember midsegments, it connects midpoint to midpoint. Right? A midsegment connects midpoint to midpoint. Now every triangle has three, and they're going to kind of make a triangle within a triangle. So if I have this triangle and I find the midpoints of all three sides, if I connect them, I have like a little mini triangle. Okay, these dashes are telling me that AD is congruent to DC, so that means this point D has to be the midpoint. It's in the middle of that side. Same thing with E, saying that CE is congruent to EB because they both have two dashes, so E must be the midpoint. With the midsegment, we have the triangle midsegment theorem, and that tells us two things. One is that it is parallel to one side of the triangle, and secondly, that it's half the length of the opposite side. Okay, so if this is my midsegment, it's going to be parallel to the opposite side, the side that it doesn't touch. Okay, and then that's what these arrows mean. And it's half as long. So if this side were 10, the opposite side would be 20. Okay, and that's the midsegment theorem. So for our example, we want to find x and z. Okay, so I know that these are my midsegments. Okay, it doesn't say it, but I'm telling you, these are our midsegments. Usually it'll have some sort of either in the given that tells you in the problem, or it'll label it. So it might say that this is congruent to this, and then these sides are congruent, and these sides are congruent. So just adding all those dashes tell me that all three of these points on the inner parts of the triangle are midsegments. Okay, so that means that this midsegment where x is parallel to this side, where 5x plus 8, and it's half as long. So that means two of these x lines make up one of the 5x minus 18. So the equation that I can write is 2 times x equals 5x minus 18. It takes two of the midsegments to get the opposite side. And now I can solve. So if I subtract 5x from both sides, we get negative 3x equals negative 18. Divide by negative 3, x equals positive 6. So that means this segment is 6, and then this side would be double that, which is 12. To find z, I know that this side z plus 8 is parallel to 3z minus 10, and it's half as long. So it takes two of these to make up one of these. So I can write an equation of 2 times z plus 8, two of the midsegments, equals 1 of the opposite side. Distribute my 2, so I get 2z plus 16 equals 3z minus 10. If I subtract 2z over, I get 16 equals z minus 10. And then my last step is to add 10 to both sides. So then we get z equals 26. So then if I plug it back in, 26 plus 8 gives me 34. And then double that over here would be 68. And so that's how you solve problems that involve a midsegment. It's parallel and half as long as the third side.